Struggling with percent problems on the SAT? Don't worry, I have got you covered. In this video, we will break down the most common percent questions, share quick shortcuts, and help you avoid the traps. Let's turn percents into your strongest topic. We know percent is per 100. So if we have x percent, we write it as x over 100. For example, if there is 20%, we write it as 20 over 100. We can simplify it as a fraction or a decimal. These are the four important formulas we have in percentage. The first is x percent of y. So we know x percent is x over 100 of is times y. So that would be x over 100 times y. When it says x is what percent of y, we do x over y times 100. So the value after of that goes to the denominator. And when the question says x is what percent greater or lesser than y, then we apply the percentage change formula, x minus y over y times 100, where y is our initial or the original value. That goes to the denominator. And when there is some x percent change on y, it could be some x percent increase or x percent decrease. So if it is x percent increase, we do 100 plus x percent. And when it is x percent decrease, we do 100 minus x percent. So like we already discussed, percentage change is final value minus initial value or initial value times 100. Suppose there is a town with population 20,000 in 1980 and 16,000 in 1990. To calculate the percentage increase from 12,000 to 16,000, we do 16,000 minus 12,000 over 12,000 times 100. To reduce your calculation, you can ignore the thousands here. So you could simply do the calculation as 16 minus 12 or 12 times 100. When a value is increased or decreased by some percentage, here is a strategy to easily find the final value. When a number is increased by x percent, you add x percent to 100 and multiply by the initial value to get the final answer. Suppose 150 is increased by 20%, so you multiply 150 with 120% to get the answer 180. Similarly, if a number is decreased by x percent, you subtract that percentage from 100 and then multiply with the initial value. Suppose 150 is decreased by 20%, so it is 150 times 80%, which would be 150 times 0.8 equals 120. So we know 20% is 20 over 100. But if we have 20% increase, then that would be 120%. And similarly, if we have 20% decrease, so subtracting 20 from 100, we get 80%. So applying this strategy makes solving easy for us in the SAT exam. So here is a lengthy SAT percentage question, which we can solve in under a minute by applying the strategy we discussed just now. So there is a commodity which has some price and there is a discount of 20% initially, and then again there is a discount of 30% on the list price. So here we could plug in 100 for the price of the commodity. So if the price is some $100, So initially there is a decrease of 20%, which is 80% of 100, that is 80. And there again, there is another discount of 30%. So 30% decrease implies it's only 70% of the value. So that is 70% of 80, which would be 56. Now 100 to 56, there is a net discount of 44%. So our answer will be C. Here is a tricky SAT math question on percentage, where again we are going to apply the percentage strategy. We are given two solutions, A and B, which are of equal quantity. And it is observed that solution A has 30% more alcohol than solution B. So let us take two solutions, A and B. And let us assume that both are 100 ml. So if B has some X ml of alcohol, now A will have 30% more alcohol. So that would be 30% increase on X. Now let us try to solve it. If X is increased by 30%, we know the percentage strategy. So that would be 130% of X. And that is given as 52 ml. So now by solving this equation, we can find X. We can simply put the equation in Desmos and we can get X as 40 ml. Now the actual question is asking for the amount of alcohol present in 250 ml of solution B. We know for 100 ml, the amount of alcohol is 40. So for 250 ml, if you cross multiply, you get the answer as 100. So this is how, if you apply the strategy, you can solve the questions very comfortably. Thank you.